Okay, welcome back to Calculus 2. So we are looking at the next problem we have here. This is probably problem 3A. So we are looking at the integral test. We're trying to figure out whether or not this series converges or diverges using the integral test. So the first thing we have to do is we have to check out the three conditions we can use for integral test. Is the function continuous? Since we have a starting place of n is equal to 2, the only time we're going to get a discontinuity for natural log is going to be natural log of 1, which is going to give us 0, and that's not happening because we're starting at 2. So we're going to say check off it is continuous. Okay. Or all of our ANs greater than 0. So n times ln of n, as long as n is larger than 1, right, then all the natural logs are going to be positive. So we have positive times a positive is equal to a positive, and we're okay with all of that. The next thing we have to make sure is this is a decreasing function. Okay, so you remember taking calculus 1? I'm sure you do. So we're going to say f of x equals that we have, go with 1 over x ln x, okay, just to make it continuous variables. And we'll go ahead and write this out like they're going to take a derivative of it. So we have f of x equals, we have x ln x raised to the negative 1 power, because I don't want to use a quotient rule, f prime of x, and then we're going to have to figure out this derivative. So we take the first piece down, we'll write down the piece from front side of it. So x now, natural log x there, to the negative 2 power. And now we need the derivative of the inside, which is going to be, of course, a product rule. So we have derivative of the first, which is 1, times the second, plus the first times the derivative of the second, which is 1 over x. Let's simplify this out a little bit. So we're going to end up with negative, parentheses, x ln x raised to the negative 2 power times, and then we have ln of x plus 1. Okay, ln of x plus 1, this is always going to be positive. Again, we can be assured that x is going to be greater than or equal to 2 for all of this. This piece is going to be positive. We have a negative out in front. Since the first derivative is always negative, we have a decreasing function. Okay, so we've checked off all three conditions that we have to work on to be able to use the integration test. Okay, next thing we're going to do is I'm going to go ahead and translate my n's into x's, so I have a continuous variable. So we're going to say, let's go ahead and check out the integral test. We're going to go from 2 to infinity of 1 over x ln of x. Now, this is an improper integral. So what we're going to do is we're going to go ahead and say, let m equal, so we have m equals the limit as x goes off to infinity, the integral from 2 to m of 1 over x ln of x, and I'll put the dx in there to make sure everything is going to be working out. Okay, so we're going to go ahead and say let u is equal to natural log of x. Du is equal to 1 over x dx. So this 1 over x dx, this piece right in here, that's my du. So here we have m is equal to the limit as x goes off to infinity, the integration from 2 to m, and we'll go ahead and say x equals, and then we have 1 over u, right, that's my natural log, and then this 1 over x dx, that's a du. So there we're ready to go ahead and integrate this thing. So we'll be able to say, okay, the integral of 1 over u du is the natural log of u, and we're going from 2 to m, limit as x goes to infinity. Okay, this is what m equals. And then we could go ahead and say, what the heck was u? U, of course, was natural log. So I have the limit as x goes off to infinity for m. Okay, and then we have the natural log of x. Okay, and then we're going to go from 2 to m. So if I plug this in, we have the natural log of m minus the natural log of 2. That's why there's a 2 there, because if we put a 1 in there, we'd end up with natural log of 0. Right, natural log of 1 is 0, and then taking the natural log of 0, that would be a pain in the neck. So natural log of 2 is a positive number. Natural log of that positive number might be negative, but that's okay. But what I'm looking for is, what is the limit as m goes off to infinity here? And I've got the natural log of m. This goes off to infinity. The natural log of x goes off to infinity is going to also be infinity. So this integral diverges. Therefore, the series diverges. Okay. So that's how you do a problem like that. Diverges. Okay, so things to look for is we're going to check our three conditions. Okay, that they are continuous. That's usually a pretty, by inspection kind of a check you're going to be dealing with. That you're going to have your ACE events greater than zero. Again, it's mostly by inspection. I'll let you hand wave a lot of that. And then we have to make sure it's decreasing. We have a test for that, and it's usually a first derivative test. So we take the first derivative and figure out what's going on with that one. So that one you actually have to show me what's going on. And then you have to show me the integration that you actually did, and then deal with the fact that we've got an improper integral and everything is working out with that one. Okay. So that's how you do a problem like that. Thank you very much for watching. I'll see you in the next video, and take care.